Good day, everyone. We are the future engineers from BSME1C, and today we'll be talking about the measures of variability or dispersion. And this subject is mathematics in the modern world.
Good day everyone. In this video, we'll be discussing about the measures of dispersion. Let's start first by defining what dispersion is. Dispersion can have a lot of definitions, but all of them have one common idea. Let's go through each of one of them first. It can be defined as a statistical term that can be used to describe the extent to which data is scattered. These are certain types of measures that are used to quantify the dispersion of data. Measures of dispersion help to describe the variability in data and are used to describe the spread or dispersion of data. So what this means is that dispersion is a term of which we can describe or use rather to describe the scatterness, the dispersion, the spreadness, or the distribution of data within a given dataset. So why do we need to learn about the measures of dispersion? Even though we do have the measures of central tendency, such as the mean, median, or mode, to determine the center value of a given set of data, there can be times where two sets of data may have the same measures of central tendency, such as the mean, median, and mode, but you need to know which of the given sets of data provides the most consistency or least variability when it comes to providing values that are as close as possible to their respective averages. Knowing this issue becomes relevant in the real world since consistency or well-spread distribution of data is important in determining which products, people, concepts, and other things to provide sets of data can be reliable to use in daily life applications. Take two thermometers for example. These two thermometers are then used to take the temperature of one person, and then the results of the temperature values are here as shown. If you try to solve for the mean or average of the temperature values recorded by the first and second thermometer, you'll get the same answers. However, by observing well how far each recorded data is from respective thermometers means, we could say that the first thermometer is more consistent in recording temperature of a person's body than the second one, due to it having closer or more precise temperature values relative to its mean, unlike with the second thermometer having values like 35.6 and 37.8, which are relatively far from the thermometer's mean of 36.7. This would therefore mean that even though both thermometers have the same average or mean temperature recorded from the same person, the first thermometer would be more reliable and practical to use when measuring temperatures from people in manufacturing and then solving it and sending it to the public. Now that we know the significance of evaluating the dispersion of given sets of data, let us now learn about the different ways that we could measure the dispersions of data, which is a range, average deviation, standard deviation, and the variance.
Let's start learning first about a well-known measure of dispersion known as range. The range is the difference between the maximum and minimum value in a set of data. This means that to calculate the range of a given data set, we must arrange all of the data in order from least to greatest. The leftmost value of the arrangement will become the minimum value, while the rightmost value of the arrangement will become the maximum value. After getting the maximum and minimum value, we then use the formula as shown to calculate the range of that given data set. Let's try this example problem. Here, we have three sets and we will assume that the data from these sets were obtained from samples. Let's try to determine which of these sets has the most variation or has the least variation. So let's start by finding the range of set A. We observe from set A and the rest of the sets that the values are already arranged in order from least to greatest. Therefore, we can easily determine the minimum and maximum value of set A and the other sets by looking at the leftmost and rightmost value of their arrangements respectively. Set A's minimum is therefore 5, while its maximum is 17. Subtracting the maximum value from the minimum value, set A's range is therefore equal to 12. Now that we have found the range of set A, We then do the same procedure to sets B and C. Following the same procedures, we get the range of sets B and C to be both likewise equal to 12. As you can see from the answers that we got, the range of sets A, B, and C are the same. This would therefore mean that the range is not enough to compare and determine the variation or the distribution of data from the three sets. We can therefore use other measures of dispersion such as average deviation, standard deviation, and variance to do so. Another important measure of dispersion includes the average deviation. At first glance, the formula for the average deviation seems complicated to remember. However, by truly understanding the definition of average deviation, we would be able to remember this formula much easier. The term average deviation can be broken down into its two words, average and deviation. Deviation refers to the amount by which a single measurement or value differs or varies from a fixed value. And in the case of dispersion, that fixed value would be the one sample mean of the set of given data. To recall, the sample mean refers to the average value of a given set of data. To calculate the deviation of a specific data from a set, that data must be subtracted from the sample mean. However, when calculating the average deviation from the word average itself, each data from a given dataset from a problem must be individually subtracted from the sample mean in order to calculate the respective deviations. Once every deviation has been calculated from its respective data value, they must be converted into absolute value and then added together. The answer to the sum of all those absolute deviations must be divided by the total number of data present in the given sample in order to finally solve for the average deviation. The total number of data can either be referred to as the population or a sample population. That is why average deviation is also called mean deviation because of how we are just essentially getting the mean of a specific set of values, which are in this case the deviations of each of the corresponding data.
So looking back at the sample problem that we have, we can then steadily calculate the average deviation of data set A, B, and C by solving first their respective sample means. So in set A, we first get the sum of all these given values together, which is 77, and then divide the sum by the population of set A, or in other words, how many individual numbers are there in set A, which is 7. Now, we have solved the mean for the set A, which is 11. We then do the same process all over again to set B and C. Now that the means of each respective data set have been solved, we then proceed to solve for the deviation of each corresponding data. So for set A, we have the first value 5. To recall the formula for solving the deviation is the specific data values subtracted from the sample mean. So in the case 5 is 5, then the subtracted by 11 equals its deviation, which is negative 6. We then do the same process toward the rest of the data in set A. So we have the division of 7, 9, 11, 13, 15, 17 respectively. Now, we have solved all the division of the data set respective value in set A. Now, we have the same procedure toward set B and C. That's the second major step of finding the average deviation of set A, B, and C now done. For the third step, all of the deviation from set A, B, and C must be converted to their respective absolute values in order to solve for the absolute deviation of each respective data set. To recall, Converting number to their absolute value is done by either multiplying them by -1 if their values are negative or remaining them unchanged if their values are positive. Therefore, the absolute deviation of set A, B, and C would look like this. Now that the all absolute deviation of each data set have been solved, the average deviation of each respective set can then be calculated. For each set starting from set A, we find the sum of all the absolute deviation and then divide the sum by its population, which is the same value used to calculate the mean of sample A, so 7.
Set A average deviation would therefore be equal to 3.428571. Do the same sequence of steps for set B and C, and we get the average deviation of set B is to be 4.285714, and the set C is to be 5.142857.
Finally, the last two measures of dispersion that we're going to discuss in this video are the standard deviation and the variance. So, what is standard deviation? Standard deviation is a numerical measure of the amount of variation in a dataset that can be used to determine whether the particular data value is close to or far from the mean. It is a statistic that calculates the dispersion of the dataset relative to its mean and is determined by taking the square root of the variance, that is standard deviation. Variance. Variance measures how far a dataset is spread out. It is defined as the average of the squared difference from the mean. It is the average of the squares of the deviation. It is presented by the symbol S squared. We can notice, based on the formulas of the standard deviation and the variance, that the standard deviation is equivalent to the square root of the variance. So basically, to solve for the standard deviation of a given dataset, we must first calculate its variance and find the square root of that variance. So then, how do we calculate the variance of a dataset? There are two ways of doing so. The first way is to use this formula that, if we observe very carefully, it has a similarity to calculating the average deviation of the dataset. That similarity would be to once again find the respective deviation of all the data present in a given set of data. However, instead of finding the absolute value of those deviations, they will be raised to the power of 2, or in other words, b squared. After finding all of the squared values of its respective deviations from the given dataset, they must then be added together, and once they are added, the resulting value shall then be divided with 1 subtracted from the sample population or population of the dataset. The same variable used to calculate the average deviation. The second way of finding the variance involves a different approach in solving by using this formula as shown. The way that this formula works basically is that we can find the variance of a given dataset without having to solve for a deviation of each data present in a given sample or set of data. That way, we're able to solve the variance of datasets whose deviations would take too long or be too large to calculate in order to save time and minimize errors in the calculations. Now, to do so, the first step we must take is to find the square of each respective data from the dataset and add all of those squared values as shown in this left term at the right side of the equation. Afterwards, we then set aside the sum of all those squared values and then proceed in solving this next term beside the previous term as shown here. To do so, we basically just have to add all of the data values in the dataset together, square that sum, and divide that squared answer with the value of the population or sample population. Once this second term is solved, we then subtract this term from the first term that we solved as shown here. Finally, the resulting difference must then be divided with 1 subtracted from the sample population or population of a dataset. In doing so, we are going to subtract the data by its mean, which is our mean is 11. So in set A, we have 5 subtracted by 11, we get -6. Next is 7 subtracted by 11, we get negative 4. And same process to do for the rest of the data in set A. So the next we get negative 2, 0, 2, 4, and 6. In set B, same procedure we have in set A. We have 5 subtracted by 11, we get negative 6. Next is 6 subtracted by its mean, which is 11, we get negative 5. And same process for the next datas. So we get negative 4, 0, 4, 5, and 6. In set C, same thing to do in set A and B. So we get negative 6, negative 6, negative 6, 0, 6, 6, and 6. Now that we have the result, we're going to square each data or raise them by 2. So, in set A, we have negative 6 square, we get 36. Next is negative 4 square, we got 16. And we do the same thing for the rest of the data in set A. So we get 4, 0, 4, 16, and 36. After getting the result, we're going to find its summation. So we get 112 for set A. For set B and C, we are going to follow the same procedure. So in set B, we get the summation of 154. And for the set C, we get 216. To compute for the variance, we must divide the result by its sample population subtracted by 1. So our sample population is 7 subtracted by 1, so we get 6. So in set A, we got 112 divided by 6, we get the variance of 18.67. In set B, 154 divided by 6, we get 25.67. In set C, we get 36. Now we get the value for the variance. For standard deviation, it's just the square root of the variance. So for set A, square root of 18.67, we get 4.32. In set B, same square root of 25.67, we get 5.07, while in set C, we get 6. Let's now use the alternative solution in finding the variance and standard deviation of the three sets. In doing so, let us first solve for the first term located in the left side of the numerator as shown. The first term involved finding the square of each data for the three sets and finding the sum of all those squares for each respective data set. We start in set A. So we have the first value, 5. We take the square of 5 and we get to 25. Next, we have 7. The square of 7 will be equal to 49. Then we do the same process for the rest of the data in set A. Let's move on to set B. We have the value of 5 again, so we then once again get 25 as a square. Next, we have 6. We take the square of 6 and get 36. Once again, we do the same procedure for the rest of set B. For set C, we repeat the same operation that we did in set A and B, and the square of the values in set C should look like this. Now that we have all of the squares of our data from sets A, B, and C, we then find the respective sum of the squares in each set. So for set A, summing the squares up, we get 959. As for set B, we get 1001. And finally for set C, we get 1063. Now we have the first term to solve for each set. We then set aside these answers and solve for the second term, which is to be subtracted from the first term as shown. For the second term, we get the sum of all the data values in its respective set. So for set A, the sum would be equal to 77, while set B and C would also obtain the sum of 77 as well. The next step in calculating the second term is to square the resulting sums for each set. Since the sum of all three sets equal to 77, the square of their sums will sort to 5,929. Finally, the last step to solve the second term is to divide those squares by the value of the population, which is 7. So we therefore divide 5,929 by 7 and we get 847. And now that we have solved the second term for all our data sets, we then subtract the second term towards the respective first term for each set. So for set A, we subtract 847 from 959, and we get 112. Then for set B, 1001 will be subtracted by 847 again. We then get the value of 154 for set B. For set C, we do the same procedure that we did in sets A and B, and then get the answer of 216. Finally, the last step to find the variance of the three sets is to divide the difference of the two terms by the population subtracted by 1. So for set A, we therefore divide 112 by 6, which is 1 less than 7, and get 18.67 as set A's variant. For set B, we divide 154 by 6, and for set C, we divide 216 by 6. Set B would therefore have a variance of 25.67, while set C would have a variance of 36. Afterwards, we can get the standard deviation for each data by solving for the square root of each set's variance. So for set A, its standard deviation would be equal to 4.32, which is the square root of 18.67. Following the same procedure to sets B and C, the standard deviation of set B is 5.07, while set C would have the standard deviation of 6. As you can see, the variance and the standard deviation for sets A, B, and C that we have solved using the alternative solution have the same values as the ones that we solved using the first solution. This therefore means that both formulas for standard deviation and variance can be reliably used for solving.
So to summarize everything that we have learned in this video, we define dispersion or variability and its importance in evaluating the reliability and or consistency of given sets of data from different quantities that can be gathered or observed in the real world. We then took a tour in learning the different measures of dispersion that we can use to quantify variability within sets of data, which are the range, average deviation, standard deviation, and variance. We then define each of these measures along with noting down the steps on how to solve each of these measures while solving a sample problem that has three sets of data for us to compare and evaluate with regards to their dispersion or variability. Finally, we then made conclusions on the dispersion or variability of the three given sets based on the different measures that we have calculated throughout the discussion of each respective one of them.
Special thanks to Kasaligan Vlogs for making this video possible. Now if you want Uno, just follow Kasaligan Vlogs.